1-to-1 or 2-to-2.
Okay, so oxygen by itself. Let's go over here. What is it? What number one is it?
Okay, I'll bring it back. Really record everything I want you to look at.
You could do that.
Separate so it says it's potassium chloride breaks down, so not potassium plus chloride. No, you potassium chloride.
So first I got
addition side. Yeah. And then it breaks into potassium chloride and oxygen. So it's oxygen plus potassium chloride. And then we put that.
How are you two doing?
Okay.
So first
Potassium chloride.
Okay. So how many potassium
That's
chloride
chlorate
compared to how many
chloride.
chloride?
It's just chloride. Chloride is just chloride.
Oh, now we're at number 4. I think what I'm going to do is you guys do the conversions, and not the beginning. Do the conversions. I'll tell you in the back. I gotta grab a paper for somebody. Yeah.
Okay, so we have 1 single figure. So how would I round 190? Good job. Jace, how you doing?
So you guys started with I wrote down the stuff that you have there.
So then you're gonna just sort of complete that problem.
So now it's to complete this.
Okay, so really close. You got the right potassium figure, but it was, so figure out what this was, 190 something, right?
How are we doing over here, guys? So far so good, just getting the equation right.
Should have been around 192. Oh, and then oxygen, for oxygen. We have O2. Oh, yeah.
Is it bad that I
And then
don't
you're
say
right.
dance?
Okay. Does that make sense? Yeah. You have to make sure you add both of them oxygens together. It says starting with brand. So I need to work out. Try that. 2 of those. 2.
Yeah. Okay, I see what it is, but no, it hasn't O2. It's just a formula.
Are you going to take it? It's hard. It'll challenge you, but it's a lot of fun. You're not going to take AP chemistry? No, why not? Guys, you don't want to.
I think I take AP chemistry and AP physics.
Oh, so I was just. Did you take AP chemistry? You could.
It's basically 8th grade science.
I was just looking across him because I was talking to. I'm sorry, Devin. Are you going to take AP chemistry? No, you're going to. Why not? Chemistry. We're not making love chemistry as much as I love chemistry.
I mean, I love chemistry, this chemistry doesn't make me fast.
What do you mean? Chemistry loves everyone.
See, with mixture and integration classes,
Yes.
American studies, and physics, then AP chemistry, and AP.
Can I have this right again? I feel better. I'm working on it. I'm working on it. Very good. That's my label.
And then whenever you're trying to find the mold of that goes on top. How are we doing?
It's surprisingly affordable. And
Okay, that was a good idea. Let's treat people with that right next to each other.
I can write numbers. Is that right?
No, I know, I'm just looking. Maybe a high five. I was just thinking of the high five. Hi. I might have. You were in your last class. So I emailed you. Or shared with you a document that has a link to a video for to do the makeup lab. So you'll need to do the makeup lab and they all have a lab. So we did our last class and then we did several. So yeah, and that, once you just one of them, you're usually doing the same numbers. So oxygen. What you can do here. So they'll go a little bit faster. They're all different problems related to that. How you doing? Okay. Well, you were at So this is grams, this has to be grams. The other thing is, this problem asks you how many grams oxygen is, and it's 32. So 32 grams of oxygen, mole of oxygen. Then you're going to look up here at how many moles of oxygen, or how many moles of potassium. Yeah. 3 and 2 on the top, 3 on the bottom, so this is going to be 1 mole of oxygen. For every 3 moles of oxygen, there's 2 moles of potassium. And then flip that, we use 32. And then I'll check on you guys again here in a second. Did you guys get all done? No. You done with the entire package? Okay, I'm going to show you how to do it really quick, and then when she's lecturing. So you're going to do actual yield divided by theoretical yield. That's how you find it. Yes. And you'll just look at when you write that's how many you actually got right divided by how many in theory. Could have more. So that's 89%. Do that first. If you look here, I'll make sure you get that. But do those two and I'll do that.
Okay.
Yep. And then if you have,
That's 6 moles.
You do multiply by 100 to make it a percentage. So you're going to have a decimal and multiply it. You guys got all done? You sure can. How are you doing on your worksheets? Are you all caught up? You don't have to read it, but you're understanding it.
And you're getting, that's the mole rate.
And you're saying you're just working on number 3, is that right? Number 2 and 3. You're a little behind because you gotta go on 2. Oh, okay, because you worked on 1. Okay. Alright, Ryan, go ahead and give one a try, please. Start with your 6 moles. Clash of Clans can wait. Or whatever it is. Not right? Not right? All right, game? He's in what? No, I don't know what that means. In Clash of Clans, so like he can't stop right now. Like me impeding upon his game time with my chemistry is okay. Whew. Thank God the rate is over. Because all that. I feel like I need to learn to play this game so I can alright kill your guys' characters so I can't play in my class anymore. Is that possible? Can I destroy it? No, I can't destroy it. Darn it. That's what my How are we doing over here? Looks good so far. Only thing, these numbers come from up here. Oh, I know why.
give you a few more minutes to work on the partner review, just because we have to move on in our notes.
3 on top. And then I think it asked you, no, that's right.
Have you started the last page yet?
How are we doing over here, guys? So far, so good? I was really
Okay, so it's telling me that 5
now I'm doing
potassium chloride.
I did her.
So, what do you get?
Yeah, I start with that. So you're at mass. So you're at grams.
What am I trying to?
76.
So what kind of mass to mass or moles to mass? So it's one step.
I can,
Using, what do you have to use?
I can take this one. And so,
Okay, so tell me, where does it say? Figure it out. It's okay. So, where does it say you find a mole ratio? From the equation. So if I told you to find the mole ratio from the equation, what would you put as how many moles?
but the two of them taught it, and then there were five of
From my
six of us, I
equation.
think, who did it. They were all in my idea what it was. He would love it. Warren Fisher.
So for my molar ratio, if I look at my example on the board, I have 2 hydrogens.
Not loud, they were all about like
My
that.
molar ratio says for every 1 mole of oxygen, I have 2 moles of water. How did I know
Yes. Peyton can swim.
the coefficient?
And
So
she-
if I'm gonna, that's my molar ratio of that hydrogen. What is my molar ratio
But the others were like,
potassium chloride to
and we
oxygen from this equation?
we just don't like to correct these in the water.
Okay, so now we have to, which goes on the
They
denominator?
told us
What
we
do
had to
we
do
have
10
to do?
blocks, and I was the only one who did it.
Okay, so how many moles of KCl do I
They
have
were
in
all like,
hydrogen? And what am I trying to find?
it's hard work.
Oxygen, so that would go on top.
My grandpa taught me that.
It was okay.
Yeah, that's it.
It was pretty, I mean, I got better in 30 minutes. The next week they're gonna teach us strokes and like how to actually
Okay, I'm gonna give you
use our
another
arms and legs.
minute to
So
work.
we're not like- Yeah, mine is doggy paddle, but they told me I got better. It was interesting. I was very nervous. Okay, so now, when you find your grade on the test, it's always your actual number. Same straight. So when you find your grade on the test, it'll say how many days of absence you've been divided by how many questions there were. And all these two things that are the same.
We are going to the pep rally today, so no one can come in.
Who
emailed you?
I don't
I emailed it back.
You already know.
And so what we have here is it says, what is the percent? It really does that 2 grams of
Hopefully it was.
7.6 grams of oxygen. These yields is an important term, because it's telling us that that's the actual, we got that much.
All right, I know some of you haven't finished the conversion partner review, but for time's sake, we have to move on. So if you would please get out for me your notebooklet and turn to page, where are we starting? Page 15, right where it says baseball's best.
Just like in a percent.
And that's where we're gonna start in our notes. If you didn't finish the conversion partner review, that's okay.
So you keep your mathematics.
That's just a quick
So you
review
try.
over everything we've done up to limiting reactants in this unit.
What page?
We're starting on page 15. So, for my last lecture, my last topic for this unit, I want to talk about percent yields. And that is probably a new term that you guys are hearing just now. But we see percent yields in almost everything that we do. One of the examples that we see in the real world is with baseball. So, in the number 1 here, we're going to talk about batting averages. My example says, Babe Ruth played in 2,503 baseball games in his career. He had 2,873 hits in 8,399 at-bats. What was his batting average? So if you don't know what batting average is, maybe talk to your partner, ask someone around to help you explain what batting averages is, but I would like for each one of you to solve what Babe Ruth's batting average was in his career. I'll give you a few minutes.
Yeah, I'm sure.
Do you know how to solve for batting average? Okay. I'll grab that for you. Zach plays baseball. Maybe I'll help you. You know how to solve for your batting. You've never calculated your own batting average before? Is it? You're always batting the Me too. Me too. When I played softball, I was batting.
Like 290, but like 290.
No, we're. What can I see what numbers you got?
45, 91.
You don't know the numbers, and I'll give you a time. I believe so.
So it's 4,591.
That's not bad.
Why is it like shut it all together?
It's so down to you can't do shit. You have to do each step, but each step is what the people. Yes. Okay, you did it as a
But conceptually you understand it, but I want to, like, I can't tell you understand it, but
But I got the right answer.
no, but you can just throw out an answer and get lucky you get the right answer.
No, because
But your steps are incorrect, so I would give you, 3 points for your answer.
That's how they said
And,
it.
1 point for writing on that one, but then you only get 3 out of 5 on that question, because then you can't tell me that you know it's
I do. What do you mean? Look,
I wouldn't give you full credit.
but if you just moved them over, you just
No,
put
you can't,
ones.
but that's not how sociology works, it doesn't work that way.
As opposed to like a free throw percentage in basketball, you don't need it.
Right.
Okay, who can tell me what Babe Ruth's batting average was?
137.
342. So that number tells me that 34% of the time, Babe Ruth got a hit. He's one of the best all-time players in baseball history, but he only got a hit or got on base 34% of the time. I think it's kind of crazy that we pay baseball players thousands and thousands, even millions of dollars to play baseball, but he really only got a hit 34% of the time. So I have another baseball player. Let's figure out if he would have had a better batting average than Babe Ruth. Hank Aaron played in 3,298 baseball games in his career. He had 3,701 hits and 12,364 at-bats. What was Hank Aaron's batting average?
How many years is that?
All right, who can tell me what Hank Aaron's batting average was? So 30% of the time, he got a hit. Jason, can you tell me how you found that?
Hits divided by that.
So you took the number of hits he has, 3,771, divided by 12,364. So how many hits he had compared to how many at-bats he had. So you guys just calculated percent yield. That is what, taking what you just did here when finding batting averages, we will just translate that into chemistry to find percent yields of chemical reactions. Another example that I have, because I know not everyone plays baseball, and I know it's a little bit hard to understand if you're not into baseball. Another example would be baking. This is what I thought of. I love to bake. I have been baking my whole life. But say I am the resident assistant at Kansas Wesleyan, so I have 12 girls on my hall that I'm responsible for. Say that if I wanted to be a nice RA and I wanted to bake each of them cupcakes. So I get a box of cupcake mix because I'm poor and I can't get the individual little ingredients. So I get one of those boxes that says, in this box, if you add, eggs and water and this little packet of the dry ingredients, I will get 12 cupcakes. So I mix it all together. I go to the little kitchenette and I mix it all together and I start putting them in the little pan to make my cupcakes. But then I find out that I can only make 11 cupcakes. And I'm a little confused because the box says that I can make 12 cupcakes, but I'm only able to make 11 with what I have. Well, then I look back and realize that, there's some still left in the bowl. Maybe I licked the spoon afterwards and I didn't put all the batter into the next cupcake. Maybe sometimes I spilled some on the floor. So those things relate to how many cupcakes that I have. Same thing that we're doing in a lab scenario. Theoretically, the numbers that we're doing in stoichiometry, we have been getting the theoretical yield of chemical reactions. But in actuality, and when we do it in a lab setting, sometimes you spill a little bit of the chemical on the counter. Sometimes you might get something else from the counter and it might mix differently and complete a reaction and have less, you'll have less product, which means you have a lower percent yield. Just like Hank Aaron and Babe Ruth, every time they go up to the plate, theoretically they can bat 1,000. Just like Zach said, his batting average is 1,000. Every time Zach goes up to bat, he gets a hit. So he gets a hit 100% of the time. But in actuality, like Hank Aaron, he only got a hit 30% of the time. So his percent yield of at-bats would be 30. So now we're going to be talking about percent yield. So if we go along in our notes, there's two parts to find percent yield. You have the actual yield and the theoretical yield. The theoretical yield is based on calculations. That's what we've been doing this whole unit. We've been doing stoichiometry to find the theoretical yield of products. So when we're trying to find our theoretical yield, you will do stoichiometry and find what that number is. The actual yield is based on the actual chemical reaction, which is what we do in the lab. Just like when I was talking about my cupcakes, my actual yield was 11, even though my theoretical yield, what I was supposed to find, or what I was supposed to make was 12. So in real life, chemical reactions do not happen perfectly. There's other outside things that interfere with our chemical reactions. So our actual yield and our theoretical yield is different. Another example of this is when we look at your grades. So I assign a point value for, let's say, your test. Say your test is worth 100 points. Theoretically, you can get 100% on the test, which means you get 100 out of 100. But actually, you might miss a question, you might forget a significant figure on the test, and I take away a point. So if you miss 7 points and you get a 93%, your actual yield would be your points, the points that you got. That would be the 93. When we solve per percent yield, the equation is the same way that you do on your goal sheets. You take how many points that you actually got divided by how many points you could get, your theoretical. Your theoretical yield would be 100. You get 100 on everything. You have the option to get 100. But because of other things, you might forget to do an assignment, you might lose points on that. Like I said, forget a significant figure. Your actual yield and your theoretical yield may be different. Then to find the percent part of it, we multiply our actual over theoretical, multiplied times 100. So I want to give you a few minutes to work on worksheet number 4, part 2, which is the very back page of your worksheet packet. Let's complete number 1 on the worksheet. It says calculate the percent yield in each of the following cases. I say the theoretical yield is a certain amount and the actual yield is another amount. Using the equation that we just went over to find percent yield, take the actual over the theoretical times 100. And you should get these answers that are in pink. So I'll be going around answering any questions, but do number 1, part A, and part B. Ooh, One Direction.
Yeah.
I love One Direction.
Are we talking about?
I was like in middle school when they became really big, so I love them. They used to have their posters. I had a poster of One Direction and I had a poster of the Twilight Capital. You should confuse. I'm not on.
There's the yield part, so we have the worksheet now.
We're on the worksheet. Okay, so here, let me. So now
I do know that, John.
that is very back page. So do A and B.
I would just try to stick to the numbers that you have, so 2 and then 3. That actually is 3 sig figs and 3 sig figs.
Worksheet freedom?
Okay, sorry.
I'll mark it down.
Now that one would only have 2 sig figs, so it would be
Oh, alright.
negative
You're
3.
done with worksheet 2.
But as long as you're not writing everything in your calculator.
Just knowing that you should know.
One Direction.
That's some quite
Did you do the A and B?
Yeah, that's what we're working on right now, just so you understand, what part two. We're just doing A and B here.
Do you have the decimal at all?
But I would like you to hurry the back pages of worksheet. Number 1, A and B. I'm giving you time to work on your homework now. It's already done. 1/4 of all of their homework. It's part 2 on the very back.
There you go. Give you guys about another minute. Check your answers with what you got on the board. I didn't look at it. Okay, I'm sorry. Jenna, let me look at your work. Good. I'm so proud of you. Good job. With the kind of maybe I'll inspire you to take it. I was looking past. You mean? I feel so bad. I was. Okay, so for each of these problems, A and B, you should have taken the actual yield over the theoretical yield and multiplied times 100 to get both of these answers. So, unfortunately, not all the percent yield problems I'm going to give you are going to be this easy. I'm not just going to tell you this is the actual yield, this is the theoretical yield, you know, divide and multiply times 100. We have to use stoichiometry to find other ones. So, when we have to use stoichiometry, if you're going along in our notes, to calculate percent yield, we first write our equation. Then, we calculate the mass of the product that should have been formed, which is our theoretical yield. Just like we talked about, theoretical yield is based on calculations, which is based on what we're doing in stoichiometry. We will calculate the mass of the product that should have been formed. And then we'll label that as our theoretical yield. We can then use our theoretical yield to help find our percent yield. This is also what we're going to be doing in our lab test next class. I'm going to give you a worksheet that says, can you make 2 grams of a compound? You're going to have to solve the stoichiometry to figure out how much reactants you need to make 2 grams of a certain compound. And what you find, you're going to also calculate your percent yield, and your percent yield will be your grade. So if you get a 99% yield, you get a 99% on your lab. If you get 100% yield, if you get exactly 2 grams, you will get 100% on your lab. So knowing how to calculate this will be important next class. The last step is plug numbers into the equation that we just gave you. So let's do an example together on how to use stoichiometry to solve these. So this example says, determine the percent yield for the reaction between 2.8 grams of aluminum nitrate and excess sodium hydroxide if 0.966 grams of aluminum hydroxide is recovered. So the first step to solving my percent yield is that I have to write my equation and balance it. So it tells me that there's a reaction between aluminum nitrate and excess sodium hydroxide. So those are my reactants. So I start with aluminum nitrate, excess, and and that produces one of my products is aluminum hydroxide. But I also look at my equation and I see that there's 2 couples reacting. So this is a double replacement reaction. So that is one of my products, so aluminum hydroxide, which means my other product would be sodium nitrate. Then we have to balance our equation. I'm going to quickly balance this. I always run out of room. And over here. So now my reaction is balanced. My next step is to calculate the mass of the products that should be formed. A big misconception during percent yield equations is that most students will want to take this number divided by this number times 100 and you think you're done. The reason we don't do this is because I'm given grams of aluminum nitrate and I need to find grams of aluminum hydroxide. They're two different compounds. Just like a batting average isn't calculated by how many catches he has in the outfield compared to how many hits he has at the plate. So we can't compare those two. We can't compare this compound with this compound. We have to get them to the same. So the next thing that I look at is I want to figure out which is my actual yield. So this word right here, is recovered, is telling me that I got this much grams of aluminum hydroxide in the lab setting. So that's my actual yield. Sometimes it'll say this reaction yielded this much, or this reaction produced this much. That is telling me that that is how much they got. So I'm going to circle that so I remember what it is. And then on to the side, I'm going to write AY. That is my actual yield. One of the hardest parts is navigating the problem. If you can navigate the problem, they're pretty simple. So now I'm given 2.8 grams of aluminum nitrate. So now I'm going to do stoichiometry to get from my grams of my reactant to my grams of my product. So I start with 2.80 grams of aluminum nitrate. 3. I'm getting from mass of my given to mass of my unknown. So it's a 3-step process if I'm looking at my map. So 1 step, 2 step, 3 step, equal sign. So now my first step says I need to find my molar mass for my periodic table. When I found the molar mass, I got 213 grams of aluminum nitrate. For every 1 mole, molar mass is always over 1 mole. NO3, 3. My next step says I need to use my molar ratio from my equation. I look at my equation, I have 1 mole of aluminum nitrate, so I write 1 mole on the bottom to cancel out my units. Aluminum nitrate. And now I want to get to what the same units my actual yield is in. So now I want to get to my mass of my aluminum hydroxide. So I'm going to go from my moles of aluminum hydroxide to my moles of nitrate to moles of aluminum hydroxide. So in this equation, I have 1 mole aluminum hydroxide. My last step tells me to find my molar mass from the periodic table. So for every 1 mole of aluminum hydroxide, I have 78 AlOH. I make sure my units cancel. Mass of aluminum nitrate, my moles of aluminum nitrate, moles of aluminum hydroxide, and I'm left with my mass of aluminum hydroxide, which is what I have circled up here. The same units as my actual yield. So now I take my calculator and I do 2.80 divided by 213 times 78, and I get 1.03 grams of aluminum hydroxide. What I just solved based on my calculations is my theoretical yield. That's what theoretically I should have gotten if I did this reaction. But my question tells me that I actually got 0.966 when I should have gotten 1.03 grams in a perfect world. So now to determine my percent yield, I take my actual yield over my theoretical yield, multiply times 100. So up here I'm going to say percent yield equals my actual 0.966 grams over 1.03 grams, times 100, sorry, times 100 equals, so I do 0.966 divided by 1.03, times 100, and I get a 93.8% yield, and that is my answer. Alright, so now I want to help you set up number 2 on the worksheet. So after we do number 2, you'll have 50% of your homework done. So I want to help you set up and navigate the problem for question number 2 on the back page of your worksheet. This worksheet, this question says we have nitrogen dioxide can be converted into dinitrogen pentoxide by reacting with ozone. The reaction of nitrogen dioxide takes place according to the following equation. And I gave you the equation and I already balanced it for you, so it makes it a little bit faster. It asks me what is the percent yield if 14.2 grams of ozone yields 7.63 grams of oxygen. So first I want to figure out what my actual yield is. This magic word here, yields 7.3 grams of oxygen, tells me that that is my actual yield. So I'm going to circle it. And I'm going to write to the side, AY. That is my actual yield. Now, I want to get my mass of my ozone to mass of my oxygen. So to set up my equation, I have 14.2 grams of ozone. Mass to mass is a 3-step problem, so I'm going to set up my problem. 1-step, 2-step, 3-step, and my equal sign. And whatever I get here, I should get my mass of my oxygen. This will be my theoretical yield. Then, once you have your theoretical yield, you solve for your percent yield. So I'll give you a few minutes to work on number 2 on the worksheet. All right? I helped you set it up, so it should go a little faster. Behind it. Make sense now? You would do oxygen 3 times to get the molar mass of ozone, yes. What do we have underlined? The O2. So we need to solve for the O2 because to solve for percent yield, we have to have them in the same units. I can do it right down. I have to think about it. You alright, Ryan? You dying? Yeah. No, this is sweet. Do you understand what's going on now? No. No? For you lost. How can I help?
On this, like,
Okay.
whole thing is-
So,
I don't know.
let's see, what do you have to do? Okay, so, the formula for percent yield is percent yield equals. You can just do percent sign if you want. Yeah, percent yield equals. I mean, the actual yield. Over the theoretical yield. Divided by the theoretical yield. Jake, you get it? So when we did this example where you were in the restroom, so solving the percent yield,
for these. I give you the actual, I give you the theoretical, multiply times. Alright, so do those two and I'll come back. 6 or 86. Okay, so you solved for the moles of ozone. Okay, so are you stuck to figure out what we're trying to solve now? Okay, so you said we have 1 mole of ozone. Good. Equation. Now we know to find our percent yield. Like I said, when you're solving like the batting averages, we didn't take the number of catches in the outfield compared to his at bats, right? We took his. Oh, we need to get it to O2 because they have to be. That's what we have circled. O2. It has to be in grams of O2 for us for it to be. Okay, so now you're gonna go from moles of O3 to moles of O2, and then solve for mass.
So I just do that.
Yep, so, so now you need to cancel out the moles of O2 and solve for the mass. I added up 1
I did it. Yeah. We don't want you to have lots of homework. Okay.
Yeah.
We have the swimming play. Okay. Yep. Grams there.
Yep, I did it really fast just because save time. You enjoy the music? Did you get the answer? Good job. Yeah, the answer's on the board. Dang it. Okay, so I want to give some of you time to do some rockets in a little bit. I'm going to go on and do help you set up one more problem on your worksheet. So if you already have this one set up, you'll be able to finish it in a little bit. But we have, I'm kind of evil, and I have to give you another step. I'm sorry, you're not going to like this. Sometimes you have to find the limiting reactant first. So we did limiting reactants last class. That's when we had 2 different stoichiometry problems. We had to solve them all the way through. Whichever is the smallest is your limiting reactant. That limiting reactant will be your theoretical yield. So now I'm adding one more step. This is the last question. I'm going to help you set up number 4 on part 2 of worksheet 4. If you can do this, you can do everything that I've taught you this entire unit. This is the end all be all, the biggest question that I can give you. So let me help you set up number 4 on part 2 of worksheet 4. So the question says, if I have 850 grams of C3H6 given in this equation, mixed with 300 grams of ammonia gas and unlimited O2 to produce 850 grams of acrylonitrile, what is the percent yield? It tells me that I have to first balance the equation. So to help you save a little time, I'm going to help you balance the equation. But if it's like you have to always make sure in this, sometimes I won't give you a balanced equation, sometimes I will, so we have to check. So to balance this equation, it's 2, 2, 3, 2, 6. So I'm going to help you out there. That would be your balanced equation. So I think I have it on another side. Okay. So my question says, I'm given the numbers of 2 reactants, but there's technically 3 reactants in this, but I said there's unlimited O2, so you don't have to solve for the 3rd reactant. If I gave you another one, you would have to do 3 stoichiometry problems, figure out what the limiting was, and then solve your percent yield. But I just give you the 2. So I'm going to help you set it up. So the first one would be 850 grams of C3H6. That's our first equation that we have to do. And it also says I react it with 300 grams of ammonia. Okay? And it tells me that I produced 850 grams of acrylonitrile. Okay? That part of on your worksheet, circle that. That will be your actual yield. It says that I actually produced 850 grams of what I'm trying to find. So that would be your actual yield. Now we're trying to find our theoretical yield. So we have to determine which one of these is going to be our theoretical yield. So, mass to mass is a 3-step problem for both of them. So I'm going to set up my 3-step problems for both reactants. And we're trying to solve for the mass of C3H3N. Mass of C3H3N. You're going to do stoichiometry to find the mass of acrylonitrile, okay? Whichever one is smaller is your limiting reactant. Remember that from last class? We had to find which one was the smallest, and that determined how much product was theoretically formed. So, when you solve these two, whichever one is the smallest is your theoretical yield. Then you'll take your actual yield, which was given to you in the problem, and you take your actual yield divided by your theoretical yield of your limiting reactant, multiply times 100 to get your percent yield. Okay? I know that's a lot of steps, but if you can do this, this is a mass-to-mass problem, which is what we did the first day. We're going to be using molar masses, molar ratios, and doing stoichiometry. Then we're going to find our limiting reactant and our percent yield. So this is one of the hardest questions that I can give you. If you can do this, you can do everything in this unit. Okay? I'll be walking around and answering questions. And I'll even put the answer on the board so you can check it after. Yeah.
We never complete worksheet number 4. It's a Saturday. Miss Mann, are we okay to start?
Yes.
Okay.